on page 253, if you take out your highlighter, and highlight this at the beginning. So if you are trying to find your x-intercepts, okay, and underline the word x-intercepts, and above it, write this, because this is true all the time. On any graph, your x-intercept is when the y value is 0. If you think about labeling a point on your x-axis, the y value will always be 0. So if you want to find your x-intercepts with an equation, you can substitute 0 in for y. If you do that with the equation that we just did, you would get negative 2x squared minus 6x plus 20 equals 0. Is that the one we did? No, this is a new one. That was the one that they did in example 1. But if you set that equal to 0 and solve it by factoring or the quadratic equation or by completing the square, the answers that you get will be your x-intercepts on your graph. So if we look at the graph that the textbook did right next door in example 1, they found x-intercepts at -5 and at 2. And if you set your equation equal to 0 and solve it, you could find your x-intercepts. So if we go back to the one that we did, can you see that we found x-intercepts at -3 and at 1? If I took our original equation, 2x squared plus 4x minus 6, 2x squared plus 4x minus 6, and I made it equal to 0 instead of equal to y, can you see that you could divide everything by 2? That changes your equation to x squared plus 2x minus 3 equals 0. This is an easy one to factor. Has to be x and x, 3 and 1, 3 positive, 1 negative. So if we solve this, we get x equals 1 and x equals -3. That's the idea that we did in all of chapter 3. So everything from chapter 3 in chapter 4, that just relates to those two specific points of the graph. Now we're adding everything else to the graph as well. If you turn to the next page, oh, I forgot to highlight one thing on this last one I wanted to highlight for you. Okay. One last thing that we can highlight. The x-intercepts of a graph are called the zeros of the function. So different language. Sometimes you're going to be asked, can you find the x-intercepts? Sometimes you're going to be asked, can you find the zeros? They mean the same thing. They're just different ways of asking the same question. All right, so if you turn to the next page, there's a pattern that happens with every parabola. And off to the side here, I want you to write when the number in front of x squared is a 1. When the number in front of the x squared is a 1, parabolas always act this way. They go over 1, up 1. This is your next page at the top of page 254. They go over 1, up 3, then over 1, up 5, then over 1, up 7. If I did it one more time, how many would I go up? 9. Okay? With the slope of a line, remember when you did the slope of the line? You always went over 1, up the same amount, over 1, up the same amount all the time. That's what the slope of a line did. With parabolas, it's a curved shape, but it does follow a pattern. It goes over 1, up 1, then over 1, up 3, then over 1, up 5, then over 1, up 7, and so on, and so on. And if you compared, that's what this is looking at, but the only thing I need you to remember from this is that basic idea that on a parabola it goes over 1, up 1, over 1, up 3. So if you can find the vertex of a parabola, and you know that the a value is 1, you'll be able to graph it quickly. So here's example 2. Okay, what we're going to look at is what happens with the y values and try and determine whether or not these are quadratic or not. The key thing is the pattern over 1, up 1, over 1, up 3, over 1, up 5. That's the idea. So what we're going to want to find out is if either of these follow that pattern or not. And this is not a very typical, if you want to say, well, we get a question like this is not a very typical question. But right now it's just sort of to get you used to the idea of what parabolas look like. So what we have here is we're starting at 2. We went over 1 and it went down how much? It went down from here to here, down 3.5. And from here to here it went down 3.5 again. And from here to here it went down 3.5 again. And from here to here it went down 3.5 again. Is it following this kind of pattern of 1, over 1, up 1, over 1, up 3? No. If it's always going the same, like this one, this is a line. It's a linear function. Whenever something does the same thing over and over again, that makes it a line. What's happened here? We went up 8.5, then 8.5 again, 8.5 again, 8.5 again. It's always going up the same amount. That makes that a line as well. We're going to find out later on, as we get more properties, that this over 1, up 1, over 1, up 3, over 1, up 5, you could double it, you could triple it, and it would still be a parabola. But we'll find out how that comes into effect later on. Okay, questions, for example, here are number 6.